Okay, so let me introduce myself. My name is Mitcha Delphine. I'm presenting my report. The title is Linear Programming Simple Maximization Method. Contains less than symbol. Okay, so other way of solving the linear programming problem is the use of simplex method. In this method, we shall only take the case where the objective is to maximize and all constraints contain the less than or equal to symbol. So this is my introduction. The simplex method uses an approach that is very efficient. It does not compute the value of the objective function at very point. Instead, it begins with a corner point of the feasibility region where all the main variables are 0, and then systematically moves from corner point to corner point while improving the value of the objective function to each stage. The process continues until the optimal solution is found. Okay, to learn the simplex method is we try a rather unconditional approach. We first list the algorithm and then work a problem. We have to justify the reasoning behind each step during the process. We will illustrate the process by way of an example where their objective is to maximize and subject to constraints using less than symbol. Here's my first example. Okay, example 1. Nikki holds two part-time jobs, job 1 and job 2. She wants to work more than a total of 12 hours a week. She has determined that for every hour she works at job 1 and job 2, she determined that for every hour she works at job 1, she needs 2 hours for preparation time, and for every hour she works at job 2, she needs 1 hour for preparation time, and she cannot spend more than 16 hours for preparation. If she makes 40 pesos an hour at job 1 and 30 pesos an hour at job 2, how many hours should she work per week at each job to maximize her income? Okay, this is my solution. So step 1, let set up the problem. Write the objective function and the constraint. Since the simplex method is used for problems that consist of any variables, we usually use the variables of x, y, z, etc. and st or u to represent the slacks variable. Okay, let x equals number for hours per week. Nikki will work at job 1. Okay, y is equal number of hour per week. Nikki will work at job 2. Maximize z is equal 40 x plus 30y. Subject to x plus y less than 12. 2x plus y is less than 16. xy greater than 0. Okay, so let's proceed to step 2. Convert the inequalities into equation. So this is done by adding one slack variable for each inequality. Observe this picture. For the objective function, negative 40x negative 30y plus z is equals to 0. For the constraints, x plus y plus s equals 12. 2x plus y plus t is equal 16. X y greater than 0. Okay, so let's proceed and step 3. Construct the initial simplex tableau. Each inequality constraint appears in its own row. The non-negative constraints do not appear as row in the simplex tableau. Write the objective function as the bottom row. Okay, now the inequalities are converted into equation. We can represent the problem into an augmented matrix called the initial simplex tableau as follows. Okay, so let's proceed and step 4. Determine the pivot column, pivot element, and the pivot row. The pivot column is the column with the most negative entry in the last row. In the table above, the column for X has the most negative entry of negative 40 in the last row. Thus, column X is the pivot column. So, I have a question here. Why do we choose the most negative entry in the bottom row? Okay, so my answer is the most negative entry in the bottom row represent the largest coefficient in the objective function, the coefficient whose entry will increase the value of the objective function the quickest. The simplex method begins at a corner point where all the main variables, the variables that have symbol such as x, y, s, t, etc. are zero. It, it then moves from a corner point to the adjacent corner point, always increasing the value of the objective function. In the case of the objective function, z is equal 40, x plus 30y, it will make more sense to increase the value of x rather than y. The variable x represents the number of hours per week Nikki works at job 1, since job 1 pays 40 pesos per hour, as opposed to job 2, which pays only 30 pesos. The variable x will increase the objective function by 40 pesos for a unit of increase in the variable x. Okay. After determining the pivot column, we then proceed with finding the pivot row. Okay. To determine the pivot row, we need to divide each entry in the constant column with the corresponding non-zero entry in the pivot column. Okay, we do not include the last row in this procedure. The row that corresponds to the smallest positive quotient in the pivot row. The entry where the pivot row and pivot column intersect in the intersect is the pivot element. Okay, so in this order, to calculate the quotient, we divide the entries in the far right column by the entries is column 1, including the entry is the bottom row. The smallest of the two equations, okay, the smallest of two equations, 12 and 8 is 8, therefore row 2 is identified. The intersection of column 1 and row is the entry 2, which has been highlighted. This is our pivot element. Okay, so observe this picture. After this, I have a question. We why do we find quotients, and why does the smallest quotient identify a row? So my answer is, when we choose the most negative entry is to the bottom row, we are trying to increase the value of the objective function by bringing in the variable x, but we cannot choose any value for x. Can we let x equals 100? Definitely not. Okay, that is because Nikki never wants to work for more than 12 hours at both job combined. Okay, so x plus y less than 12. Can we let x is equal 12? Oh, again, the answer is no, because the preparation time for job 1 is 2 times the time spent on the job, since Nikki never wants to spend more than 16 hours for preparation. The maximum time she can work is 16 divided 2 is equal 8. Okay, using the equations to identify the pivot element guarantees that we do not violate the constraints. So the pivot row then is the second row, and the pivot element is 2. Note, the pivot element should be plus 2 if not divide each entry in the pivot row by the pivot element. The resulting row will be used and the pivot row. Okay, there's a question here. Why do we identify the pivot element? Okay, my answer is, as I have mentioned earlier, the simplex method begins with a corner point and moves to the next corner point, always improving the value of the objective function. The value of the objective function is improved by changing the number of units of the variables. We may add the number of units of the of one variable while throwing away the units of another. Pivoting allows us to do just that. Okay, so the variable whose units are being added is called the entering variable, and the variable whose units are being replaced is called the departing variable. The entering variable is the above table is x, and it was identified by the most negative entry in the bottom row. The departing variable variable t was identified by the lowest of all quotient. Okay, now for the next table, we use pivoting to obtain the row echelon form of augmented matrix. So pivoting is a process of obtaining one in the location of the pivot element, and then making all other entries zeros in the column. So now our job is to make our pivot element. One by dividing the entire second row by 2. The result follows is here in the above picture. Okay, to obtain a 0 in the entry, first above the pivot element, we multiply the second row by -1 and add it to row 1. We get? Okay, to obtain a 0 in the element below the pivot, we multiply the second row by 40 and add it to the last row. Okay, so We now determine the basic solution associated with this tableau by arbitrarily choosing y is equal 0 and s equal 0. We obtain x is equal 8 and s is equal 4. Okay, so and z is equal 320. At this stage of the problem, it reads that if Nikki worked 8 hours at job 1 and no hours at job 2, her profit Z will be 320 pesos. Our corner points is S is equal 4 and T is equal 0, mean that she will never left with 4 hours of working time and no preparation time. Okay, so let's proceed the step 5. When there no more negative entries in the bottom row, we are finished. Otherwise, we start again for step 4. Okay, since there is still a negative entry, negative 10 in the bottom row, we need to begin again from step 4. This time we will not repeat the details of every step. Instead, we will identify the column and row that gives us the pivot element and highlight the pivot element. Okay, observe this picture. Okay, we make the pivot element 1 by multiplying row 1 by 2 and we get this. Okay, we no longer have negative entries in the bottom row, therefore we are finished. Okay, I have a question here. Why are we finished when there are no negative entries in the bottom row? So my answer is lies in the bottom row. The bottom row corresponds on the equation 0x plus 0y plus 20s1 plus 10t plus z equal 400. Okay, or z is equal 400 negative 20 y and negative 10 t. Since all variables are not negative, the highest value z can ever achieve is 400, and that will happen only when s and t are 0. Okay, so we now read of our answers. That is, we determine the basic solution associated with the final simplex tableau. Again, we look at the columns that have a 1 and other entries zeros. Since the columns labeled S and T are not such columns, when arbitrarily choose S is equal 0 and T is equal 0, and we get the matrix reads x is equal 4, y is equal 8, and z is equal 400. The final solution says that if Nikki works 4 hours at job 1 and 8 hours at job 2, she will maximize her income to 400 pesos. Since both slack variables are 0, it means that she will have used up all the working time as well as the preparation time, and none will be left. Okay. Okay, so let's proceed. Example number 2. Suppose a company manufactures different electronic components for computers. Component A requires 2 hours for fabrication and 1 hour for assembly. Component B requires 2 hours for assembly. The company has up to 1,000 labor hours for fabrication and 800 labor hour for assembly time each week. If the profit of each component A and B and C is 7 pesos, 8 pesos, and 10 pesos, respectively, how many of each should be proceed to maximize profit? So, first, first thing we have to do is to set up the problem. So we are gonna make our objective function and subjective to constraint. Step 1, let x be the number of component A, while is equal b the number of component B, s is equal b the number of component C. Maximize P is equal 7x plus 8y plus 10s, x, y as less than, greater than 0. So, subjective to 2x plus 3y plus 2s less than 1000. Okay, x plus y plus 2s less than 800. Step 2. Okay, we have to convert our inequalities into equations. Okay, so for the objective function, negative 7 x negative 8y negative 10 plus p is equal 0. For constraints, 2x plus 3y plus 2s less than 1000. So, x plus y plus 2 uh, s less than 800 with x, y as greater than 0. Okay, let's go to step 3. We have to set up our simplex tableau. Okay, so observe this picture. So we will determine our pivot column, pivot element, and the pivot row. Okay, so in the table above, the column S has the most negative entry of negative 10 is the last row. Okay, so those column S is the pivot column. Our pivot row is 2 because it has the smallest quotient, and our pivot element is also 2. Okay, so let's proceed to step 5. After determining our pivot column, pivot element, and pivot row, we are able to pivoting to obtain a 1 of the allocation of pivot element and all entries of this column. So now we have to divide entire second row by 2 to make our pivot element a1 pivot a 1. Observe this picture in the above. Okay, so we have to divide 1 over 2 in the row 2 to get our new row 2, and we get ayan, look this picture in the above. Okay, so and then we have to get our new row 1 by dividing 2 in the row 2 and add the row 1 to get our new row 1. Okay, so now our job is to get also the new row 3 by dividing our pivot column, which is negative 10, but we have to change it to positive and it becomes 10, so we can get a 0. Okay, observe this picture in the above. So in the table above, we have all our new rows, but unfortunately we are not finished yet because it is not yet 0 in the x and y, so we have to repeat what we do in step 5. Okay, so we divide, so we have to divide the first row in 1 over 2 to get our new row 1. Okay, so observe this picture in the above. Then we have to get again our new row 2 and row 3 to get the new row 2. We have to divide again 1 over 2 to row 1 and add row 2. After that, we have to divide positive 3, which is our pivot column, to row 1 and add row 3 to get the new row 3. Okay, so observe this picture. Observe this picture. The table above shows us that finally there is no negative in the row 3, which is we are done. Okay, so our solution is maximum when x is equal to 100, s is equal 300, y is equal 0, t is equal 0, u is equal 0, max profit of 4,400 pesos. Okay, so that's it. This is our end of our video reporting, and thank you so much.